Alright, so in this video I'm going to finish where I left off for section 4.5, and then I'm going to do a couple of example problems from your homework in this section. So you can see how to do them in Pearson and get an idea of what will be on your test. So remember we were talking about the horizontal asymptotes of a function, and down here in case 3, if the degree of the numerator is larger than the degree of the denominator, then there is no horizontal asymptote, but I said that there may be an oblique asymptote. So we are going to talk about what an oblique asymptote is and how to find it. Now, on your exam, you will not have to find an oblique asymptote on this exam 2. But I will be doing an extra credit assignment for anyone willing to learn how to do this and they want to get some extra credit. This won't be the only extra credit assignment I'll assign, but this will be one of them, which will have to do with finding an oblique asymptote. And I'll post an announcement regarding the extra credit assignment when the time comes. That'll be sometime after our second test. Okay, so an oblique asymptote occurs when the degree of the numerator is greater than the degree of the denominator by 1. So it's only greater by 1. So a couple examples would be like f of x equals x cubed over x squared plus 2. This would have an oblique asymptote because 3 is 1 greater than 2. So this function has an oblique asymptote. So the top degree is larger than the bottom, so there's no horizontal asymptote, but there is a oblique because the top is greater by only 1. If it's greater than by more than 1, then there's no horizontal or oblique asymptote. Now to find the equation of oblique asymptote, this is where it is pretty challenging. And I had another student tell me that they don't even ask you to find this in your homework, so I'm trying to make sure that's correct, but I'm still going to go over it because it's good to know. And if you're going to a higher math class after this, then you will definitely be seeing this again and having to do it more in depth. So it's good to see it now. So to find the equation of an oblique asymptote, we're going to actually perform the division of the fraction. We're going to divide the numerator by the denominator using long division. Okay, so you may have remembered doing this either in high school, long division of polynomials, or if you took intermediate algebra, you would have seen it there as well. Okay, and then this last part says there can be only one horizontal asymptote or one oblique asymptote, but never both. So let's do this first example. It says find all asymptotes of the function f of x equals 2x squared minus 3x minus 1 over x minus 2. So again, it's asking us to find all asymptotes. So first we will find the vertical asymptote. Now again, we must factor the top and the bottom first, so we determine whether there's holes in our graph. But for this one, the top, the numerator, can't be factored. So we would leave it just like this. This can't be factored, this numerator. because there's nothing that will multiply to give you -2 and add to give you -3. Okay, so next thing we're going to do to find the vertical asymptote is set the denominator equal to 0. So that's how we find vertical asymptote. So we're going to set x minus 2 equal to 0 and solve. And of course, that gives us the vertical asymptote of x equals +2. So that is our vertical asymptote. And again, that's that vertical line the graph will never touch. Okay, and then for the horizontal asymptote, we have that the degree of the numerator is 2, and the degree of the denominator is 1. So the top is larger than the bottom. So when that happens, there is no horizontal asymptote. So if there's no horizontal asymptote, there may be an oblique asymptote. And there is, because 2 here is only 1 greater than 1. So it's greater by 1, which is when we have an oblique asymptote. And so to find this, we will set up the long division. So we're dividing the numerator, 2x squared minus 3x minus 1 by, so the numerator goes underneath our long division symbol, and we're dividing that by x minus 2, which is our denominator here. Okay, now if you remember long division of regular numbers, the steps were divide, multiply, subtract, bring down, repeat. If you don't remember that, I would highly suggest that you go look up a YouTube video and remind yourself of just long division of numbers first. And then come back and watch this video for the long division of polynomials. Okay? But the steps are really the same. They go in the same order. The first thing we're going to do is divide. But with polynomial long division, you're only going to divide the first term, 2x squared, by the first term on the outside. So we're going to divide 2x squared by x. And when we do that, we get 2x, because x squared divided by x is just 1x, and the 2 is still there, so that's 2x. And so that answer goes on top of my long division problem. And then the second step is to multiply the answer I just got, 2x, by the entire divisor here, x minus 2. So I'm taking this 2x and I'm multiplying. So when I multiply, I have to distribute that 2x. So 2x times x is 2x squared, and 2x times -2 is -4x. So that answer gets written right below. And then the next step is to subtract. And what I'm subtracting is the like terms by the like terms. So, sorry. I have 2x squared minus 3x on top. And then I'm subtracting 2x squared minus 4x. So let me just write out what I'm doing. 2x squared minus 3x. And then we're subtracting 2x squared minus 4x underneath it. But that means I need to put it in parentheses and distribute that negative. Okay? So you're subtracting both terms. So 2x squared minus 2x squared, that would cancel. But negative 3x minus a negative 4x, that double negative on the bottom would become positive, so it would end up being negative 3x plus 4x, which is just 1x. So you have to distribute the negative, because anytime you subtract any polynomial from another polynomial, you have to distribute the negative. Okay, and that gave us the answer of x. And now step 4 is to bring down the negative 1. So we haven't done anything with this negative 1 right here. We used the negative 3x when we subtracted, so I don't bring that down. I've already used it, but I haven't used the negative 1, so I'm going to bring down that negative 1 there. And then finally, I will start over. I will repeat. So I start back at divide. So I divide this first term here. In my previous answer, x minus 1, after I brought the minus 1 down, I divide that x by the x, the first term of the divisor. So x divided by x. X divided by x is 1. And so just like I did with the 2x in the very first step, I'm going to put the 1 at the top, and I got a positive 1, so I'm going to write plus 1 there. I'm going to add that term to the top. And then I'm going to multiply that 1 I just got by all of that divisor again. Let me erase that though. So that'd be 1 times x minus 2, which is just x minus 2. Okay, and so I wrote the x minus 2 at the bottom, and now I subtract. And I'm subtracting the x minus 1 minus x minus 2. So I need to distribute that negative. So I'm technically doing x minus 1 minus x plus 2. The x's would cancel. Negative 1 plus 2 is just 1. So x minus 1 cancels. Negative 1 plus 2 is 1. All right, now I'm done because 1 would be my remainder. I can't divide. I don't have anything else to bring down. I can't divide 1 by x, so I'm done. This is my remainder, but that doesn't even matter. The remainder here does not matter for the purpose of what I'm doing. What I'm trying to do is find the oblique asymptote. So the final answer for the oblique asymptote comes from the answer at the top, 2x plus 1. And it'll be of the equation y equals. So the final answer for the oblique asymptote is y equals 2x plus 1. And again, that came from the top up here, 2x plus 1. And that would be the full equation, y equals 2x plus 1. That would be the equation of my oblique asymptote. And so oblique asymptotes, these are not horizontal or vertical lines. They're just regular lines. They're still invisible lines that our function kind of tends to as it gets close to that line. But it won't touch it on one end. It could touch it at some point, but on one end it will not touch it. All right, so that is how you find an oblique asymptote. Now finally, the last part of this section is putting all this information together and graphing these rational functions. Oh, and then one more thing I want to say, since I'll be doing an extra credit assignment of this with the oblique asymptotes. If you don't quite understand this long division of polynomials based on my video I just did or what I just showed you, there are a ton of resources out there on YouTube for doing long division of polynomials. And they have color-coded, step-by-step examples. So if you're interested in doing that extra credit, I would definitely start looking at some of those videos to get a better understanding of how to do that. Okay, so on your Pearson homework and on the exam, the graphs that they will be asking you to graph for these functions, they'll be giving you like multiple choice of different graphs. And so you'll use all this information to narrow down the possibilities for these graphs. And so here are the 5 things that you can do to use your process of elimination and find the correct graph of the function. So the first one is to find any real zeros of the denominator. And that means set the denominator equal to 0. Should know that by now. And solve for x. And of course, this is what we've been doing to find our vertical asymptotes. So then after you set the denominator equal to 0 and solve for x, these will be the equations of your vertical asymptotes, and it will give you the domain of the function because the domain will be all numbers except for those values. So we've done that. The second thing is to find the horizontal or oblique asymptote, if there is one, and then sketch it. Now remember, all 3 of these, vertical, horizontal, and oblique asymptote, any kind of asymptote is just an invisible imaginary line. So when we say sketch it, you can sketch it like, let's say this is my graph, and I have a vertical asymptote at 2. I could do like a dotted line to sketch it on my paper. All of this is on my paper for right now. You always want to sketch these by hand on your paper first, and then you can compare it to the multiple choices in Pearson. But that's how you could sketch a vertical asymptote, just a dotted line. to show that, okay, this is where it is, but of course it's imaginary, so it's not really there if I were to like graph it on a graphing calculator. Okay, number 3, find any zeros of the function. Now we have found zeros of many functions up to this point, but we have not done that with these rational functions yet. So we're going to be doing that in this example here. But you know, this is the same thing we've been doing. You set the entire function equal to 0, and then you solve for x. Now I'm going to show you with this example here that that's the same thing as really setting the numerator equal to 0 and solving for x. So to find the x-intercepts, remember these are x-intercepts, zeros of a function are x-intercepts. You set the numerator equal to 0, top of the fraction. And solve for x, and that will give you your x-intercepts, which of course these are points that you can plug in, that you can graph on a function. Number 4 is to find the y-intercept by plugging 0 in for x to the function. So in this example, to find the y-intercept, I'd plug 0 in for all of these x's here. And we're going to do that, but not right now, not yet. So of course, again, this gives the y-intercept of the function. So that's another point that you can graph or compare on the graphs that they give you. And then finally, step 5, if they give you a bunch of multiple choices that are almost exactly the same, you can find other function values to determine the general shape and to compare and narrow it down even further. So let's put all of this information together and do this example here. So first, I'm going to find the domain and the vertical asymptotes. And I'm going to do that by first factoring the numerator and the denominator. So the numerator is already factored, so that'll just stay as 2x plus 3. The denominator, I'm going to write this over here. A little like scratch work here. Here's my denominator. To factor this, I need to multiply a times negative 6. Or, sorry, a times c, which is 3 times negative 6, which is negative 18. And the two numbers that multiply to give me negative 18 and add up to give me 7 would be 9 and 2, negative 2. 9 and negative 2. Okay. So that means I will replace my middle term here. Oh, sorry, my iPad's, okay. I'll replace my middle term, the 7x, using my two numbers, so plus 9x minus 2x, and then minus 6. And then I factor by grouping. So I can pull out a 3x in the first group to leave me with x plus 3. And then I can pull out a negative 2 in the second group, which will leave me with x plus 3. And so this factors to x plus 3 times 3x minus 2. So this is my scratch work for factoring the denominator. Okay. All right, now nothing cancels or simplifies, so we're good on that. Now to finish finding the vertical asymptotes and the domain, I need to set the denominator equal to 0 and solve. Okay, so I take each factor and set it equal to 0. I would subtract 3 to both sides on the first one, so x equals -3 is one of my vertical asymptotes. And then I would add 2 to both sides, and then divide by 3. So x equals 2/3 would be my other vertical asymptote. And then my domain would be all real numbers except -3 and 2/3. X cannot equal -3 or 2/3 because that's what makes the denominator equal to 0. So on a number line, if they wanted me to do this in interval notation, I could sketch it on a number line first because it makes it easier to figure out the interval notation. So both of those would be open circles because it cannot equal those two numbers. But it can be anything else. So in interval notation, this would be from -infinity to -3 with the parentheses. That's the interval all the way on the left. And then -3 to 2/3. That's the interval in the middle that's shaded in blue. And then it starts at 2/3 and goes to positive infinity. So this is my domain in interval notation. X cannot equal -3 or 2/3. Okay, so that's step 1. Step 2 is to find any horizontal asymptotes. So the degree of the numerator is 1 because of the exponent, 2x plus 1. The exponent on x is just 1. That's the highest exponent of the numerator. And the degree of the denominator is 2. That's the highest exponent of the denominator. So the top degree is smaller. 1 is smaller than 2. So when the top degree is smaller than the bottom, the horizontal asymptote is y equals 0. Smaller degree on top, small horizontal asymptote. Okay, now because there is a horizontal asymptote, of course there's no oblique. So we can move on to step 3. I'm going to probably have to make this smaller. I'm running out of time here, or running out of room. Okay, so 3 was to find zeros of the function. So to find zeros of this function, which are x-intercepts, we just set the numerator equal to 0 and solve. Now, why is that? Let me say set numerator equal to 0 and solve. Well, normally for any other type of functions, we would just take the entire function, 2x minus or plus 3 over, I'll just go ahead and write it in its factored version here. It doesn't matter. And I would set this equal to 0. And then I would solve for x. Well, this is a rational function, so I need to get rid of the fraction, which means I need to multiply both sides by the common denominator of x plus 3 times 3x minus 2. But whenever I do that, on the left side, they will all just cancel, leaving me with the numerator. And on the right side, that would just be 0, because 0 times anything is still 0. So that's why it's the same thing as just setting the numerator equal to 0 and solving. So I would subtract 3 to both sides. And then I would divide both sides by 2. So x equals -3/2 is my x-intercept in terms of the point 0, -3/2. So this would be the 0, and this would be the x-intercept. All right, so let me get a new sheet, and we will just sketch this graph by, by hand. And then I'm going to show you some examples on Pearson of what it will really be like, because you'll just be picking multiple choice, really. All right, so first thing we're going to do is sketch the vertical asymptotes. So we found them to be -3, here, and 2/3. These are my vertical asymptotes, -3 and 2/3. So I would have 1, 2, 3, -3. My iPad pencil is going crazy. Why are you doing that? Okay, so there would be an invisible dotted line. We can just make it a dotted line at x equals -3. And then 2/3 would be between 0 and +1. So somewhere like right here. So this is x equals -3 and x equals 2/3 for my two vertical asymptotes. Okay. And then my horizontal asymptote was y equals 0. So that, again, is a horizontal line at y equals 0, which is just the x-axis. And that is an imaginary vertical line, so I'm just highlighting the x-axis. Oops, what just happened? Okay. All right, and then we found the zeros of the function to be, or just 1 0, 0, -3/2. -3/2 is a little bit greater than -1. So that would be right here. This would be my x-intercept. -3/2, 0. Oh, I'm sorry. I put that in the wrong order over here. But the -3/2 would come first. It's an x-intercept. Okay. So that would be an x-intercept on the x-axis. And again, -3/2 is a little, sorry, I said greater. It's less than -1. It's -1.5. So that would be right in the middle of -1 and -2. All right, now we can find the y-intercept. We haven't done that yet, so that's step 4. So I'll actually move this down a little bit and write that above it. Oh, why are you doing this to me? Oh my goodness. Okay, y-intercept. So now we're going to plug 0 in for x to our function. So that would be 2 times 0 plus 3 over 3 times 0 squared plus 7 times 0 minus 6, if I'm remembering that correctly. 3x squared plus 7x minus 6. Yep. Okay, so 2 times 0 would be 0. 0 plus 3 is 3. This would be 0. This would be 0. 0 minus 6 is -6. And this would simplify to -1/2. So the y-intercept would be 0, -1/2. So that would be, here would be -1, so that would be right in between here. I'll just write -1/2 right here. Okay, so that's my y-intercept. Now, let's see what my function is doing. Now, as you can see, we have an x-intercept. So of course that shows that this function's going to be crossing the horizontal asymptote, which is fine. So let's do step 5 and find some additional values. Now at this point, like I said, on your homework, you won't be doing most of these by hand. You'll just be picking the graph that has all of these properties so far. So some of them will have different vertical asymptotes, and you'll know that that's not the correct choice. Give me 1 second. Okay. All right, so what we're going to do now for step 5 is I'm going to pick some values in each of these intervals to figure out what my graph is doing. So in the middle, remember, these vertical asymptotes, our graph will never touch, but everything like in the middle of these two green lines will be continuous. So because I already have 2 points there, I already kind of know that this is decreasing from left to right. So it's going to be like coming like this and then going down, getting really close to my function. You'll kind of see that that's true. Now I could plug in 1/2 and see that it's going to be down there, but that's what happens with these rational functions. They tend to those vertical asymptotes. So those 2 points already told me that it was decreasing from left to right, so I know it's going to be going down and getting really close to that vertical asymptote, and then this left side is going to be going up and getting really close to that vertical asymptote. And you could have picked a value for x, say like -2 here, plugged it in, and got a point just to show that that was true, that it was going to be up here. And you could have also picked a point over here, an x value over here, and found that point there. But I'm just telling you that if you already have those 2 points in between those vertical asymptotes, then you kind of know that it is going to have this shape. So now what I'm going to do is pick a value to the left of that first vertical asymptote. So let me pick -4. And I'm going to see at the value of -4, is my function above the x-axis or below? Will it be positive or negative? So when I plug in -4, this would be 2 times -4 plus 3 over 3 times -4 squared plus 7 times -4 minus 6. 2 times -4 is -8. -8 plus 3 would be -5. And then on the bottom, -4 squared is a positive 16. 16 times 3 is 48. 7 times -4 is -28. 48 minus 28 is 20. And 20 minus 6 is 14. So this would be -5 over 14. And so that is a negative value. And it's going to be like, that's in between 0 and -1. So here's -4 on my y-axis. -1 was over here. So that point would be somewhere like right here. I plugged in right here. I plugged in -4 and I got -5 over 14. It's below. So what does this tell me? Well, I know that the middle part has already crossed the x-axis right here. The x-axis, because that was my x-intercept. And that's the only x-intercept I have found. So my function will not cross the x-axis anywhere else. So I know for a fact that this side has to be going down and tending to my horizontal asymptote. And this side's going to be going up and tending to my horizontal asymptote. But if you don't know that, if you didn't remember that, you could find a couple more points and get a general shape. But they will be continuous, you know, in between the vertical asymptotes. So now finally, I'm going to pick a value over here. I'm going to pick 2 on the right of that the right vertical asymptote. And when I plug in 2, I get 2 times 2 plus 3 over 3 times 2 squared plus 7 times 2 minus 6. 2 times 2 is 4. Oops. Oh my gosh, this thing is driving me crazy. So this would be 4 plus 3 over 2 squared is 4. 4 times 3 is 12 plus 14 minus 6. So this would be 7 over 20. So that's positive. So that'd be somewhere like right here. That gave me the point 2, 7 over 20. Let me draw some colors. Okay, now again, I know that this is not going to cross the x-axis, so it has to be tending to the x-axis that way and then tending to my vertical asymptote this way. Oh my goodness. I don't know why it's doing that. So this would be the general shape of that graph. All right, let's do some of these on your homework. First one I'm going to do is this one. Graph the following function, determine the asymptotes, if any. List the domain and x-intercepts and y-intercepts. Check working using a graphing calculator. So if you see at the very top, it says part 1 of 7. So there's 7 parts of this problem. The first one it wants us to find is the domain. So I'm going to write this here, hopefully. And we're going to go through. So Again, first thing they want me to do is find the domain. To find the domain, I just need to know the value that makes the denominator equal to 0. And that value would be 6, because 6 minus 6 is 0. So x cannot be equal to 6. And in interval notation, that would be from negative infinity to 6, parentheses, because it can't equal it, union 6 to infinity. So that would be the domain, and that's what it wants. Type your answer in interval notation. Just bear with me. Okay. Negative infinity. Did it just... oh my gosh. Negative infinity to 6. Union. 6 to infinity. Okay, so that's the domain. Now it wants me to find the x-intercepts of the function. So for the x-intercepts, we need to factor the function first and simplify. Because remember, if our function has a common factor in it, then that creates holes in my graph at that x value. So if there's a hole in my graph at that, if there's a common factor, there's a hole in my graph there, then there will not be a point at that x-intercept. So I'm going to factor and simplify first, and then figure out my x-intercept. So x squared minus 36 is a difference of two perfect squares. So that factors to x plus 6 times x minus 6 on top. And then we have the x minus 6 on the bottom. So therefore, this function will have a hole in its graph. Because of that common factor of x minus 6, and x equals 6 is the 0 of that common factor. So the only value that will give us an x-intercept is what's left, which is the x plus 6. So I take x plus 6 and set it equal to 0. So x equals negative 6 is my 0, or x-intercept. And this would be in the form of point negative 6 comma 0. So you need to factor and simplify before finding x-intercepts or vertical asymptotes. Everything else you use the original for. That's why we didn't factor and simplify before we found the domain. Because 6 still makes that domain or that denominator 0, and it makes that function undefined. So if I go back here, this says that the x-intercepts are the function r, and it says to type an ordered pair. So I just found that to be negative 6. Why won't it let me? 0. Okay, now it wants us to find the y-intercept of the function. So to find the y-intercept, you can plug 0 into the original or the simplified one. It actually doesn't matter there. But let's just plug 0 in for x to the original. So that'd be 0 squared minus 36 over 0 minus 6, which would just be negative 36 over negative 6, which would be positive 6. So the y-intercept would be 0 comma 6 is the y-intercept. And you want that to be in the form of an ordered pair. So that would be 0 comma 6. Okay. The next one is the vertical asymptote. So that's what makes that denominator equal to 0, which is we already found to be x equals 6. So that would just be x equals 6. Oh, I'm so sorry. I forgot. Look at me, forgetting. Remember, to find the vertical asymptote, we need to factor and simplify first. So let me go back and explain. So I've said this a few times. Vertical asymptote, you must factor and simplify first. So we already factored it for our x-intercepts. And so these two common factors of x minus 6 will cancel, leaving me with just x plus 6. So there will be nothing in the denominator. So therefore, there is no vertical asymptote. How do I get out of that? So the function has no vertical asymptote. Horizontal asymptote there would be no horizontal asymptote. Because if we're just using the answers of the degree, the degree of the top is larger than the degree of the bottom. Because the degree of the top is 2 and the degree of the bottom is 1. So there would be no horizontal asymptote. Now, remember that, and I'll write this, horizontal asymptote, no horizontal asymptote since 2 is greater than 1 on the degrees. Okay, oblique asymptote. Remember we said that there's an oblique asymptote if the top is greater by 1. But when we simplified it, we were just left with a linear equation. So there actually is no oblique asymptote either. So if your common factors cancel and you're left with a linear equation, then there is no degree on the bottom. So there will be no oblique asymptote. So now let's pick the correct graph. So because when we simplified there was no vertical asymptote, we see that all of these look like almost linear equations. They're all linear except for they have a hole in its graph. And you can see that if you zoom in, they have a hole down here at -12 on this first graph. And a couple of them have some holes here at their graph. Okay, so let's go back so we can pick the right graph. So we said that there was a hole in the graph at x equals 6. And then because these simplified, we're kind of looking at, and then also, sorry, let's back up. There's a hole in the graph at x equals 6. There's an x-intercept at -6, 0. So if we go back to our graph, forgot what I said. The hole in the graph is at x equals +6. Okay. So +6 on the right side of the y-axis. So it's not A, because that hole in the graph is to the left. That would be a negative x value. Here, I'll show you. The x value associated with that hole is -6 up there. Well, we didn't say it was at -6. We said it was at +6. So it's not A. It's not B, because that hole at the top up there to the top left is also at -6. So it's not B. So it looks like it's either C or D right now. Both of those, I think, are going to be at +6 for that hole. Yep, and +6 for that hole. Okay. And then we said the x-intercept was -6. So that one lines up. There's an x-intercept at -6. Right up there on the x-axis at -6. But I think this one also has an x-intercept at -6. So it could be that one also. So don't just pick that other one because you've seen that it had those two properties. You got to keep going. What was our y-intercept? Our y-intercept was +6. So that means it has to be D, because that is the one that has a y-intercept at +6. So it's just kind of process of elimination there. Okay, now that was probably one of the hardest ones you'll see on your homework. The rest of them shouldn't be that hard. But I just wanted to pick a hard one there. So let's do this one. And then we'll be done. x minus 4. Actually, we'll do one more after this. But this one won't take me as long as the other one. It's minus 28, right? Okay. All right, so same steps. We're going to find the domain of this first. Okay, so domain. We will set the denominator equal to 0 and solve. This can be factored to x minus 7 and x plus 4. And so we get that the solution to this equation would be x equals 7 and x equals negative 4. So actually, since we're finding the domain, x cannot equal these values. So x can be any other number but these values because they make the denominator equal to 0. So on a number line, if I plotted negative 4 and 7, these would be open circles. And so my domain would be from negative infinity to negative 4, union negative 4 to 7, union 7 to infinity. So that would be my domain in interval notation. Okay. Second, my vertical asymptotes would just be x equals 7 and x equals negative 4. Because first of all, let me actually back up a little bit. Moving a little too fast. If I factored this function, which I've already did, the top is just x minus 4, the bottom is just x minus 7 times x plus 4. They don't have any common factors. So these are the two vertical asymptotes. The horizontal asymptotes, the degree of the top is 1, and 1 is less than 2. So the horizontal asymptote is y equals 0. Small horizontal asymptote. My x-intercepts, I take my numerator and set it equal to 0. So x equals 4 is my 0 or my x-intercept. Should be the point 4, 0. And my y-intercept would be what I get when I plug 0 in for all the x's. So that would leave me with negative 4 on top and negative 28 on the bottom, which would be positive 1 over 7. So that would be the point 0, 1 over 7. Now, because we got a horizontal asymptote up here, there's no oblique asymptote, because there can either be an oblique or horizontal. Okay, so let's see what we got. Domain, they want an interval notation. So that would be negative infinity to that, what did I say, negative 4. Union negative 4 to 7. union 7 to infinity. X-intercepts we got from setting the numerator equal to 0 and solving, and we got that the x-intercept was 4. So that would be 4, 0. The y-intercept we found to be 0 and then a fraction 1/7. Vertical asymptote, there was 2 of them, and that was at -4 and 7. So the leftmost vertical asymptote would be x equals -4, and the rightmost was x equals 7. The horizontal asymptote was y equals 0. And there was no oblique. Now let's put this all together. We had 2 vertical asymptotes. So it's definitely not going to be A, because there's only one vertical asymptote here in A. It's not going to be D. This is what a oblique asymptote would look like. It would be like a regular dashed line, because that's not vertical or horizontal. So we didn't have an oblique, so it's either B or C. So now we're looking at the vertical asymptotes. There was one at -4 and 7, right? -4 and 7. So let me see if that lines up. This one, 2, 4, 6, 8, 10. Yeah, okay. So that's -2 all the way to the left, that vertical asymptote. 2, 4, 6, 7. So that lines up. We found the horizontal asymptote to be y equals 0. So that looks like it's lining up. So let's look at the other one real quick. So the other one is 2, 4, 6. Okay, so the other one's saying that it's at -7 on the left. So that's not right. So that goes ahead and narrows it down to B. That's the one that matches up. Okay, so that's the complete answer for that problem. Okay, and then I just want to do this one and we'll be done. X minus 5 and x minus 5, x plus 4. So this one should be pretty easy. I don't have to factor it. So the domain is all numbers except for -4. Because x cannot equal -4. That's what makes the denominator equal to 0. So in interval notation, that would be from -infinity up until -4. And then -4 to infinity. The vertical asymptote would also be x equals -4, because we find the vertical asymptote by setting that denominator equal to 0 and solving. So that would be our vertical asymptote. Horizontal asymptote, the degrees are the same on the top and the bottom. They both are 1. X and x, both on the bottom. So the horizontal asymptote is y equals the same thing in front, which is 1/1, which is just 1. Y equals 1. Okay, the coefficients there are both 1. 1/1 is just 1. So there's no oblique asymptote. The x-intercept we get by setting the numerator equal to 0 and solving. So x equals 5 is the x-intercept, so 5 comma 0. And then the y-intercept is from plugging 0 into the function, which would be 0 minus 5 over 0 plus 4, which is negative 5/4. So that gave me the point 0 comma negative 5 over 4. So let's do that one. So again, that would be from negative infinity to negative 4, union negative 4 to infinity. The x-intercepts is what we got when we set the numerator equal to 0. And that gave us the ordered pair, 5, 0. That's what makes the numerator 0. The y-intercept, we got that by plugging 0 in for x. And we got the fraction negative 5 over 4. The function had one vertical asymptote at x equals negative 4. The function has one horizontal asymptote, and that was the equation y equals 1. There's no oblique asymptote. And then let's compare. So the vertical asymptote is at negative 4. X equals negative 4 was our vertical asymptote. So that eliminates A and B because the vertical asymptote is positive over here at positive 4. So is this one, or it's, yeah, positive 4. So that leaves either C or D. And then our horizontal asymptote was a positive 1. So that's just going to leave C because D, if I pull up D, that horizontal asymptote is at negative. It's a negative value. I think it's negative 1 there. So the correct answer is C. So it's just process of elimination with all that. I know it's a lot. It's a lot of steps and it's a lot to remember. But again, you have your flashcard and you can put these rules on your flashcard. You just need to practice them and do them a few times. But this will be the end of 4.5, and this will be the last thing we do before our next exam. And I'll be posting a review video on Monday.